So, how do we actually learn? And I'm not talking about just mindlessly memorizing facts from a textbook through endless repetition. I mean that deep, profound kind of learning, where a super complex problem suddenly just makes complete sense. Welcome to today's Explainer, where we're going to dive right into the incredible science behind human and, well, primate understanding.
Think about it. Have you ever been completely stuck on a problem? Maybe it's a tricky math equation, a really stubborn coding bug, or even just trying to pivot a ridiculously awkward piece of furniture up the stairs. You hit a total wall, you take a step back, and then boom, absolute clarity. We all know that feeling, right? That is the universal experience of the aha moment. And decoding exactly how that sudden realization happens, well, that's the whole foundation of our explainer today.
Now, to really understand this aha moment, we have to kick things off with the concept of Gestalt. It's a German word, and what's kind of fascinating is that there's no exact English equivalent for it. The closest translation we have is something like configuration, an organized whole, or the totality of a situation. Gestalt psychologists firmly believed one core thing. The whole is fundamentally more important than its parts. Basically, when we learn, we aren't just absorbing isolated random bits of data. We're perceiving a situation as a complete, unified puzzle. We look at the different relationships, and then we intelligently make our move.
So, here's our roadmap for today. We'll start with the aha moment, then meet Sultan the clever chimp, move on to decoding insight learning, look at the Gestalt laws, and wrap up with the impact on education.
All right, part one, the aha moment.
We've got to start with Wolfgang Kohler. He was a prominent Gestalt psychologist, and man, was he deeply frustrated with the traditional psychology of the early 20th century. Back then, the field was totally dominated by associationist theories. That's just a fancy way of saying they thought learning was purely random trial and error. You try something blindly, you get a reward, you slowly learn to do it again. But listen to this quote from his 1959 address to the American Psychological Association. He said, "What had disturbed us was the utter senselessness of this picture, and the implication that human life, apparently so colorful and so intensely dynamic, is actually a frightful bore." He literally couldn't stand the idea that learning was just mindless mechanics. And comparing these two approaches brilliantly illustrates the divide. Think about associative learning. This was famously demonstrated by researcher Edward Thorndike, who basically put cats in puzzle boxes. The poor cats would just thrash around randomly until they accidentally bumped a release lever. But then, compare that to Kohler's apes, representing insight learning. Kohler argued, no way, real learning isn't just a gradual, mindless accident. It happens when you use actual reasoning to mentally map out your environment. It's a sudden, one-shot restructuring of how you view the problem.
Which brings us to Section 2, Sultan the clever chimp.
To prove his theory, we're going to transport ourselves to a primate research center in the Canary Islands. The year's around 1913, right as World War I is effectively stranding Kohler and his chimps out there. So, Kohler sets up an experiment. He puts a chimpanzee named Sultan inside a cage. He hangs a bunch of bananas completely out of reach, and he leaves a simple wooden box on the floor. Now, initially, Sultan does what you'd expect. He applies old routines. He jumps, and he fails. But, and here is the crucial part, instead of thrashing around blindly like a cat in a puzzle box, Sultan stopped. He paused all overt behavior. He looked at the bananas. He looked at the box. And then, in a sudden flash of insight, he realized the relationship between the two. He literally dragged the box over, used it as a jumping platform, and grabbed his reward.
But Kohler wasn't going to stop there, right? He made the puzzles harder. After mastering the single box, Sultan quickly had to figure out how to stack 2 or even 3 boxes to reach the fruit. In another challenge, the banana was placed outside the cage, and Sultan was given 2 short sticks. When he realized one stick wasn't long enough, he didn't just throw a tantrum and give up. He had another bright idea. He actually joined the 2 sticks together to make a longer tool. This proved absolutely conclusively that Sultan was using true cognitive reasoning. This wasn't random chance, it was intelligence.
Okay, moving on to Section 3, decoding insight learning.
So, what's actually happening in the brain here? Well, insight learning typically follows a very specific 3-phase pattern. Phase 1 is the initial effort. This is where you, the learner, apply previously learned strategies, kind of like Sultan just jumping for the banana. Then comes Phase 2, impasse and incubation. You hit a wall, you realize your old routines definitely aren't going to work, so you pause. You abandon physical trial and error, and you switch over to cognitive trial and error. And finally, we get Phase 3, insight development. This is the sudden aha moment where your internal reasoning process successfully finds a brand new functional relationship to solve the problem.
Now, Gestalt psychologists actually broke this whole process down into 8 detailed steps. But honestly, it helps to just think of it as a journey. First, as a highly motivated learner, you identify and understand the problem. Then comes the real magic, the incubation phase. This is that hesitation, that crucial pause where your brain is quietly churning away on the task. You might test a few responses out in your head, keeping your attention sustained on the ultimate goal until, bam, step 6, insight development. It's like a flash of lightning. And finally, you repeat that adaptive behavior and fully comprehend your new ability. You own that skill, and you're ready to use it next time.
Curler defined this phenomenon so brilliantly. He said, "When we are aware of a relation, this relation is not experienced as a fact by itself, but rather as something that follows from the characteristics of the objects." Okay, what does that actually mean for us? Essentially, it means true learning isn't about just absorbing isolated facts. It's about grasping the functional relationships right in front of you. You stop seeing a simple wooden box, and your brain starts seeing a jumping platform. It's a total perspective shift.
Let's jump to Section 4, the Gestalt laws.
So how exactly does our brain group these relationships together so incredibly fast? Well, one foundational concept here is the law of similarity. It's basically our brain's natural tendency to perceive different sets of objects as continuous groups or patterns, rather than just isolated things. This law is what leads us to automatically link elements together to form a pattern that actually makes sense. It's what allows us to step back and see the bigger picture.
And honestly, equally important is goal orientation. Learning by insight does not just happen passively. It is a highly purposeful, goal-directed task. For this aha moment to occur, the learner has to be deeply motivated and intimately acquainted with their objectives. Think about it. Sudden insight doesn't happen without a reason. Sultan didn't invent a climbing platform just for fun. He was intensely laser-focused on the goal of reaching that banana.
Finally, Section 5, Impact on Education.
So you might be wondering, why is a century-old primate experiment incredibly vital for the modern classroom? Because it gives us absolutely crucial, actionable takeaways. Since we know learning happens as a whole, teachers really need to present concepts holistically, not chopped up into fragmented parts. We've got to arouse intrinsic motivation, making sure students actually have a clear goal they care about. And we need to fiercely avoid mindless, mechanical repetition. Instead, tasks should perfectly match a child's intellectual capacity, advocating for a truly child-centered approach. Ultimately, the whole point of education is to develop a student's reasoning power. We want to build their capacity to discover facts for themselves, rather than just spoon-feeding them bookish knowledge.
Insight learning proves that when we hit a wall, just thrashing around isn't the answer. So, the next time you hit a major obstacle in your own learning journey, how will you step back, look at the whole situation, and engineer your very own aha moment? Take that pause, let those ideas incubate, and let your reasoning do the heavy lifting. Thanks so much for joining me for this explainer, and hey, keep looking for those brilliant flashes of insight.